Hello students, today we will see the last topic in the data link layer devices. First is the bridges. Bridges operate in both physical layer and data link layer of the OSI model. As a physical layer device, it regenerates the signals it receives. As a data link layer device, the bridge can check the physical, that means the MAC addresses. Bridges can divide a large network into smaller segments. Then a bridge monitor the information traffic on both sides of the network so that it can pass the packet of information to the correct location. Then first type of the bridges is filtering. Bridge has filtering capability. A bridge has a table used in the filtering decision. Then bridge check the destination address of the frame and decide whether frame should be forwarded or dropped. If the frame is to be forwarded on which port, then this decision is taken by the bridge by using some tables. Here the one of the table, this figure shows the LAN connected by the bridge, and if frame is destinated from the stations, here the stations 712, then 42, here the 442, then it arrives at the port 1 and bridges check a table to find it. According to table frame, first one is the 712 B 13 45 61 42 live through port 1, and therefore there is the no need for forwarding, the frame is drop. If a frame for these 41 which arrives, here the 41 which arrives at port 2, the frame is forwarded. A bridge does not change the physical address in the frame. This is the bridge connection of the two LANs. Here the bridge, and here the LAN 1 and LAN 2, and these are the bridge table. Here the port 11 and port 22. Then next type is transparent bridge. A transparent bridge is a bridge in which the stations are completely unaware of the existence of the bridge. If a bridge is added or deleted from the system, reconfiguration is unnecessary. A system equipped with a transparent bridge must meet three criteria. And remember these three criteria. First one is the frame must be forwarded from one station to another. Then second is the forwarding table is automatically made by learning frame movement in the network, and third one is the loop in the system must be prevented. Then forwarding means a transparent bridge must correctly forward the frames. Then here the third type is bridge spanning tree. For increase the reliability, it is desirable to have the redundant alternative path from source to destination, and with multiple path cycle, result bridge may multiply and forward frame forever without the frames being dropped. And solution is to organize the bridge in spanning tree by disabling subset of the interfaces. Here the spanning tree is the graph in which there is some loops, and that means here 0 loops, and in bridges LAN we create the logical topologies to avoid the loop by having one or only one path from any LAN to the other. Then here the first source routing bridge. In the source routing, the source of each packet defines the bridge and LANs through which the packet should go before reaching the destination. Then in the other word, the frame contains not only the source and destination address but also addresses of all the bridges to be visited. Then the source routing bridges are uses some information provided by the packet sources to determine the path and packet to be taken. Then the bridge, here the total frame route is embedded in one frame so that it allows the bridge to make the precise decision of how the frames is forwarding using the network. By using this method, two similar network segments are connected to the data link layer. Then the bridges connecting different LANs. There are many issues when the bridge connected to the LANs. First one is the frame format. Each LAN has its own frame format. Second one is the maximum data rate. If an incoming frame size is too large for the destination LAN, then bridge required to fragment it and then reassemble it at the destination LAN. But the fragmentations and reassembly of the frames are the functions of the network layer, and bridge is working in the data link layer. So bridges just discard these frames. Then here the third issue is data rate. Each LAN has its own data rate. Consider faster LAN as a sender and the slower LAN as a receiver. So the bridge must buffer the frames to compensate the speed differences. Then fourth is a bit order. Each LAN has its own method of sending of bit, and some send the most significant bit in the byte first and others send the least significant bit first. Then fifth is a security. Wireless LAN implements security in the data link layer and wired LANs do not. Then here the security involves encryption. When a bridge receives a frame from wireless LAN, it need to be decrypted first and then forward. And last one is the multimedia support. Some LAN supports multimedia and some not. Then last topic is remote bridges. Remote bridges is a bridge that connects two geographically separated networks by using a telecommunication service such as the plain old telephone services POTS, lease lines, or the circuit switch services. A remote bridge has at least one local area network, that means LAN port, such as for example RJ45 jack for an unshelled twisted pair UTP LAN connection to a switch or hub, and at least one serial port, such as suppose here the RS232 port or the V.35 interface. The serial port is synchronous for digital lines or asynchronous for the modems. Then the bridge might have both synchronous and asynchronous serial port. Remote bridges can also be enabled for the simple network management protocol, that means SNMP, and have other diagnostic and support features such as the out of band management OBM supports. Here the remote bridges concept. So here the end of our fifth chapter, data link layer.